In this problem, we need to verify the statement that the medians of a triangle are concurrent with the help of vectors. Okay, let us begin. So first, we will consider a triangle ABC. Now, this triangle, the vertices ABC are going to be represented by some position vector. That means we have an origin O. So if we join the origin with the three vertices, then we get the three position vectors. So we're going to assume that let A vector, B vector and C vector be the position vectors of the vertices A, B and C respectively of the triangle. Now we'll be considering 3 points. Let's consider the point D. Now D is going to bisect the side BC. And then we have the point E. E bisects the side AC. And then we have the point F. F is going to bisect the side AB of the triangle ABC. Now what we'll do? We'll join point A and point D. Similarly, we'll join B and E and C and F. And they are going to be the median of the triangle ABC. Now, let's say the three medians A, D, B and CF meet at a point G. This will be our goal. We need to show that the three medians are concurrent, means they meet at the same point G. Now, we have the medians AD, BE and CF. Now, our next task will be to find out the position vector of the point D, E as well as F. We'll start with position vector of the point D. Now since AD is median on BC, it means that D divides BC into ratio 1:1. So here we can use the section formula to find out the position vector of the point D. Therefore, OD vector, that means position vector of the point D, that will be equals to 1 multiplied to the position vector of the vertex C added to 1 times the position vector of the vertex B. So that's B vector divided by 1 plus 1. So that's going to give us C vector added to B vector divided by 2. So now we have the position vector of A, so that's A vector. We also have the position vector of D, which is B vector plus C vector divided by 2. Now we know by definition that the point G is going to divide AD in the ratio 2:1. Now since G is dividing AD in the ratio 2:1, again we can apply the section formula to find out the position vector of the point G. That means OG vector, that will be simply equals to, we'll take the help of the diagram. So here we have 2 times the position vector of D. We have 2 times OD vector added to 1 times the position vector of the point A, or the vertex A, divided by 2 plus 1. Now that we have OD vector as well as OA vector, so let's replace this value. So we have 2 times C vector plus B vector divided by 2 added to 1 times A vector whole divided by 3. Simplifying this, we're going to get A vector plus B vector plus C vector whole divided by 3. And this is going to be the position vector of the point G, or we can say the position vector of the centroid. Similarly, we can show that if we consider this median CF, which is where G is also dividing it in a ratio 2:1, we can also show that G is going to have the same position vector A vector plus B vector plus C vector over 3. And when we take the median B, then again also we can say that the position vector of G is also going to be given by A vector plus B vector plus C vector whole divided by 3. So this proves that the median of a triangle ABC are concurrent. That means they have a common centroid.